This video accompanies the paper RoPotter, toward robotic pottery and deformable object manipulation with structural priors. Previous works on deformable object manipulation often focused on tasks that involved little to no visual occlusion of the deforming object. They also tended to involve discrete and staged action observation sequences. Approaching deformable object manipulation with imitation learning can address these limitations. However, previous works on imitation learning for deformable object manipulation focused on tasks that were short horizon and on flat, non-volumetric deformable objects. In this work, we introduce a novel task of robotic pottery making. During pottery making tasks, our hands often occlude the deforming clay. The task also necessitates continuous deformation of the clay and continuous actions. Deforming a lump of clay into a meaningfully different shape, such as a bowl, is also a long horizon task. We used a 7-degree of freedom robot arm and positioned a standard pottery wheel in its workspace. To teleoperate the robot, we used a gaming console controller to do end effector position and orientation control. To perform the pottery task, we center the clay by hand on the wheel and spray water throughout trials to keep the outer clay surface lubricated. RoPotter has two RGBD cameras that can observe the clay deformation. We track the positions of two colored markers to track the pottery wheel orientations and register the point clouds together. In this work, we take advantage of two structural priors of the pottery making task: radial symmetry and mechanics. Cross-section representation of the observed clay reduces the dimension of the observed point clouds, while the mesh-based pipeline recovers occluded points in the clay during interactions. We collected 40 demonstrations each for a wide bowl and a tall bowl. We trained two behavior cloning policies with our proposed flattened representations and a policy on the raw 3D point clouds as baseline, and evaluated against demonstrated bowl shapes. We varied the amount of clay on the pottery wheel to demonstrate the policy's robustness to different initial conditions. In all cases but one, our proposed methods performed the best. We introduce RoPotter, a system for robotic pottery making. We leverage structural priors to reduce the dimensionality of the clay state representation and recover occluded shapes. We demonstrate behavior cloning pipelines and use the proposed representations for clay shape. Results show that the proposed methods both outperform the state-of-the-art baseline.